Lab 1, charge tapes. The objective of this experiment is to determine the amount of excess charge on a piece of tape and observe the transference of electrons between two pieces of tape. We use Newton's law and Coulomb's law to calculate the original charges on each piece of tape and the electric force between them. This experiment resulted in the steady piece of tape starting to float due to the electric force between the two pieces. The fundamental principles used in this lab are Newton's second law, which is force equals mass times acceleration, and Coulomb's law, which is force equals the K constant times Q1 times Q2 over R squared. For this experiment, I denoted the system as the piece of floating tape right here, and then I denoted the surroundings as the piece of moving tape. My initial tape length was 0.18 meters, the tape width was 0.019 meters, the distance between the tapes was 0.034 meters, and the tape mass was 0.00018 kilograms. So to calculate, I used F equals ma for the force of gravity, and then I denoted the force of gravity as equal to the electric force. And then using Coulomb's law, I plugged in the numbers to find the electric charge, which I got right here. And then I found the charge divided by the number of electrons right here. And then I found the ratio of electrons to atoms, which is right here. So next, I made a glow script code, and I used Newton's law and Coulomb's law, and I used my initial conditions, and I plugged all of those in right here. And then right here, I plugged in my Newton's law and Coulomb's law. And with this, I was able to find the charge of the piece of tape and the Q over E, and then also the ratio of E to atoms. So with this predicted data, it differed a little bit from my experimental results, but it still produced pretty similar results. And the sources of error in this could be from me touching the tape accidentally and neutralizing it, or it could be from unequal charges, because with the previous equation, we assumed that Q1 and Q2 would be equal. However, they may not have had the same charge, and this could be an error. So with my conclusion, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? Well, the observations would be the same, but they'd be flipped, because in this case, if the tapes lost electrons, their charge would become more negative, as opposed to the tapes becoming positively charged due to a loss of electrons. And then, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? By touching the tapes or bringing them in contact with other objects, the tapes lose their charge and become more electrically neutral. So that's why it's important to not bring the charged tapes into contact with any objects outside of the system. Thank you.